Alright guys, I want to talk to you about the step that we use in the scientific method. Most of you have seen these, but I always want to go back and talk about them really quick. Remember, there's several steps that we're going to look at. These steps are fluid, so we can use them how we need them in our scientific method. But before you do this next lab, I want you to review these simple steps, and there's 5 that we want to make sure we always include. The first step being we have to have either a problem or maybe a question of some kind. Okay? Those are the first 2. Next one, hypothesis. This is where we write our hypothesis about our question. Okay? Okay? So our hypothesis is often written from here. There's a third step. A third step comes in as next thing we're going to do after we've written a hypothesis and we have a question or a problem we want to answer, we are going to do some research. And the reason we're going to do research here is because what if the answer to our problem or question or even our hypothesis has already been answered? We don't want to do all that work again, so we do the research to make sure that it hasn't been answered before. So that's where this comes in. Next step. Once we've discovered that this hasn't been answered, there's no answers to it, and our research tells us that, we go on to doing an experiment. And this is where you're going to test your hypothesis. Okay, and remember that a hypothesis, for it to be solid, it has to have 3 parts. It has to be if, and because. And we'll talk about that here in a little bit. Okay, so we've got the 3 parts. It also has to be testable, and that's the big part. Okay, so we want to make sure that our hypothesis is always testable. Alright guys, so I want to take a little detour. Even though we're talking about scientific method, I want to take a detour on how to write a hypothesis and what a real hypothesis is. We just can't continue on any farther, so that's why I got this little detour here. Now, when we talk about hypothesis, the most thing is a useful hypothesis must be testable, okay? Now, if this hypothesis is not testable, it really is not any longer a hypothesis. The thing is, a hypothesis is a tentative statement that proposes a possible explanation for a phenomenon or event. Now, that goes back to our question or problem. Typically, these are surrounded around phenomena or even events, especially in the earth sciences. We have events that we try to explain. So we would use a hypothesis to explain them and then possibly test them if we have to go that far, if it's possible. And remember, it's supposed to be testable. So this is what the problem is. A lot of the hypothesis pieces on, let's say, for example, Bigfoot. Guys have lots of hypotheses on these animals existing, but testable is really tough unless they actually really want to find this thing. It really isn't a good hypothesis in that case. So that's why science has trouble with some of these things, even though they are trying to answer them. So that's a different subject, though. A hypothesis should not be confused with a theory. Keep in mind, what a theory is a theory is a possible explanation as to a series of events, and there's data that's collected over years and much experimentation done to explain it. So this would be a theory. So an example of that would be, for example, evolution. Okay, for man sharing a common ancestor. This is a possible theory, okay? Whereas a hypothesis, when we use a hypothesis, we're trying to explain and develop a test to test that hypothesis about that explanation. So it's about usually a smaller piece of that. Now, this is all not to be confused with a law. For example, a law, for example, may be Newton's laws, where if I take this pin and I drop it, well, you know that every time I let go of this pin, it's going to fall. This is a law. So there's 3 different terms we've talked about here. We've talked about laws. Okay, we've talked about theory, and of course the hypothesis. Okay, all mean very different things. Okay, make sure you've got that in your notes that you understand the difference in these 3 different things. Okay, clear this off. Let's go to the next slide. All right. Now, when are hypotheses used? Hypothesis, of course, is, there it is again, testable. Talked about this several times. They have to be testable. And what it is, that is, you will perform a test on how two variables may be related. So what we're trying to do is we're trying to change two different variables that may occur. Usually a hypothesis is based on some previous observations, such as noticing that in November many trees undergo color changes in their leaves and the average daily temperature is dropping. So you can see that there's two variables that have changed here. The main one being temperature change throughout that time of the month causes the leaves to change. So this is what they're trying to explain. Any laboratory procedure you follow without a hypothesis really is not an experiment. At that point, it's kind of a cookbook lab, and we do those in class where you're expected to follow the directions, go step by step, and get a certain result. We know that's going to happen. A good experiment, you would be writing a hypothesis, testing a hypothesis somehow, and I like to bring that in the class as much as we can as well. So you'll be doing that throughout the semester. All right. How do we write a hypothesis? First thing you must do in order to develop a hypothesis is have a question. So we have to come up with a question of some kind. If you have that question, then you can start working on that. Remember, step one, problem or question. Next thing is to write the hypothesis, so that's where we're at. So for example, if we have a question, we want to write our hypothesis in the form of if, then, and because statements. If we write them in those statements, normally it gives a good baseline for how we're going to end up with a good hypothesis. So in this case, when we talk about if, what if does is it identifies the subject for us. What are we talking about? Okay. The if is, are we talking about mice? Are we talking about plants, etc.? You have to include that, or otherwise we don't know what you're talking about in your hypothesis. Next part is the then part. The then piece states what's being measured, how are we going to change it, what are we checking, their rate of growth, their height, their weight, etc. This connects that. And then conditions, what are we going to do to them? How are we going to adjust them? So the then is going to include both of these pieces, okay? So then has this part, both B and C is the then. That's how it's answered in your hypothesis. And of course the A part is the if part. Okay? And then the final part is the because. This is our prediction. What's going to happen? What do we expect to happen? What do we expect to see happen? Why is this happening? This is what we're going to include in our hypothesis. This is the because part, the last one, which is actually in reality a prediction. Okay? That's our prediction. All right, so how do we go about doing this? Let's erase this stuff. All right, so if I give you a question, which is the first step, will plants grow in different color lights be affected? So this is it. This is the question. How are plants going to grow when the lights are different if we change the color of the light? The hypothesis I wrote for this, if bean plants grow under dark color light more slowly than plants that are grown under bright light. So here's the if part. What am I looking at? Bean plants. What am I going to do to them? Okay, then we grow two different plants. The then part, of course, includes what am I going to be doing to them under two different plants, one under dark light and one under bright light. So we have one dark light, one bright light. Of course, the variables here. And then my prediction, because the plants grown under bright light will grow faster. And that's my prediction. Now, what if I'm proven wrong and the dark light grows them faster? Well, that doesn't mean that I'm 100% wrong. I'm one step closer to the right answer. But my hypothesis may be wrong, and I can rewrite my hypothesis. That's why in our scientific method, we have to often move back and forth in those steps. All right, guys. So this is how you write a hypothesis. From here, what I want you to do is I'm going to give you some questions to look at. I want you to write a hypothesis for each of them. So finish the video, then come see me for those questions, and I'll give you those. All right. See you later. And if it's testable, then we can go on to do our experiment. Whoops. Do an experiment if our research doesn't answer these things. And then the final step, we do our data. This is where we end up with data, and we're able to make conclusions from here. Okay, and in this class, of course, the conclusions include quite often a lab report. Okay, and that may be in your journal where you're going to handwrite those, or you may have to do a formal type up. It all depends on the lab. All right, so these are the 5 main steps. You have to have a problem or a question, come up with a hypothesis, we do some research, make sure they haven't been answered, we do an experiment, we do data, or from our experiment we end up and yield either data, and because of that we're able to do conclusions, and then or a lab report and report on what we found and what we understand. All right, take some notes on this stuff, go back and look at it again. We will use this continuously throughout this class, so make sure you have it. Good job.